Bright Duty. Every student matters.
Now, ABCD is a parallelogram. AE is perpendicular to DC. So, this angle is 90 degrees and CF is perpendicular to AD, that means this angle is 90 degrees. If AB is 16 centimeter, so this length is 16 centimeter and we know ABCD is a parallelogram. So, the opposite side will be equal to AB, that is 16 centimeter. So, DC is also 16 centimeter. AE is 8 centimeter. So, this height AE is 8 centimeter and CF is 10 centimeter. So, this altitude from C to AD is 10 centimeter and we need to find AD. We have to find AD. Now, it is very simple to think about this question, because if it is a, let us say, parallelogram, and if I consider this as my base, then this will be the altitude, right. So, let it be h, okay, and this will be, this be b, this side is b and let it be h. So, area of this parallelogram will be base into height, okay. But if I consider this side as base, let us say b2, and then what will be the height? Now, I will have to drop a perpendicular from this side to this side, right. So, let me drop the perpendicular here. Let us say this is the perpendicular this time, okay. Now, this will be the height. So, area of this parallelogram is also equal to B2 into H2. Hence, these two areas are equal, right, because we are talking about the same parallelogram here. So, similarly, in this case, if I consider DC as my base, so DC into AE will be area of parallelogram DCBA, right. And if I consider AD as my base, so AD into altitude CF will be the area of parallelogram DCBA, right. So, I can take any of these sides as base and then I will have to see the height accordingly, right. So, these are the same area, right, we are talking about area of same parallelogram. So, these have to be equal. So, DC into AE is equal to AD into CF. So, what is DC? DC is 16 centimeter, AE is 8 centimeter and it is equal to AD, that is to be calculated, into CF, that is 10. So, AD is equal to 16 into 8 by 10, right. 16 into 8 is 128 and it has to be divided by 10. So, AD is 12.8 centimeter, okay. So, we are just talking about the area of same parallelograms, area of the same parallelogram. It is just that we are using different bases, right. Once I used this side as the base, so I will get this as my height, the perpendicular to this and joining the upper vertex, and when I consider this side as my base, I will have a different altitude, right, but their product will be same, because we are talking about area of same parallelogram. If EF, GH are respectively the midpoints of the sides of a parallelogram ABCD. First of all, let us draw this so that we can visualize it easily. So, there is a parallelogram ABCD and EFGH are respectively the midpoints. So, E is the midpoint of AB, F is midpoint of BC, G is midpoint of DC and H is midpoint of AD. Now, if you notice, this segment is equal to this segment, and as AB is equal to CD, so their halves will also be equal. So, this segment is equal to this segment. This may not be used in this particular question, but you should be careful about these things, that you always mention like these things. So, that this segment is equal to this segment and is equal to this segment and this segment. Why it is important to mention? Because once you visualize the question, once you visualize the figure, it will be very easy for you to comment on the answer. So, this segment is equal to this segment, this portion is equal to this portion, right, because these are midpoints. And if I now join E, F, G, H, right. Now, I need to show that this area of quadrilateral E, F, G, H is equal to half of area of A, B, C, D. So, let me make you understand it first, then we can write it together. Okay. So, now see, these two lines, that is AB and DC, are parallel. Okay. If I draw a line passing through the midpoints H and F, will this line be parallel to these two lines? Yes, it will be parallel. Why? Because this line here is parallel to this line and this segment is equal to this segment. So, if opposite sides of a quadrilateral are equal and parallel, then that quadrilateral is a parallelogram. So, in quadrilateral ABFH, AH is parallel to BF because ABCD is a parallelogram, right, and AH is equal to BF. I have given you the reason. So, we can say ABFH is a parallelogram, right. If opposite sides are equal and parallel, then it is a parallelogram. Now, can I say that triangle HFE and parallelogram HFBA lie on same base HF and between same parallel lines HF and AB. Hence, area of triangle HEF will be half of area of parallelogram HFBA, right, because we have got a triangle and a parallelogram which lie on same base and between same parallels. So, area of this triangle will be half of area of the parallelogram. Now, this area is half of this parallelogram HFBA. What can I say about this area? Area of HFG will also be half of area of HFCD. Same reason, right. This is a triangle and a parallelogram on same base HF and between same parallel lines HF and DC this time, right. So, give the reasons here. Now, if you add the areas of these two triangles, area of triangle HEF plus area of triangle HFG on the right hand side, if you add areas of these two parallelograms, you can notice that the sum will be area of parallelogram ABCD, right. So, I will directly write it as area of parallelogram ABCD here. Now, this area is nothing but area of this quadrilateral, which is also a parallelogram that you will study in midpoint theorem, right. So, this area is nothing but area EFGH. Hence, proved that if you join the midpoints of sides of a parallelogram, you will get a quadrilateral inside, which we will study that it is another parallelogram. Anyhow, that quadrilateral that is made by joining these midpoints will have area, half of the area of the outside parallelogram. This is what we had to prove here. P and Q are any two points lying on the sides DC and AD respectively of a parallelogram ABCD. So, let me try to draw this. Let us say this is parallelogram ABCD, ABCD. P and Q are lying on DC and AD. So, P is lying on DC and Q is lying on AD, right. Show that area of APB, that is this area, area of triangle APB is equal to area of triangle BQC, that is this triangle. Right. Now, if you understand a simple logic that triangle APB and parallelogram ABCD lie on same base AB and between same parallel lines AB and CD, then you can say that area of triangle APB is half of area of parallelogram ABCD, right. Now, in triangle CBQ and parallelogram, let me start with CBAD, let me call it CBAD, so that you can relate that now I am talking about this base CB. Now, these two figures lie on same base. What is the base I am taking this time? CB, and between same parallel lines BC and AD, BC and AD, right, because we already know that this is a parallelogram. So, this line is parallel to this line is parallel to this line, okay. Hence, because of this I can say area of triangle CBQ is half of area of parallelogram CBAD. Now, if you look at this equation and this equation, on right hand side I have got area, half of area of ABCD, half of area of CBAD, which is nothing but ABCD. So, their right hand sides are equal. So, their left hand sides will also have to be equal. So, if I call them equations 1 and 2, by comparing equation 1 and 2, I can say area of triangle APB is equal to area of triangle CBQ, right. So, if I have to say it in brief, what I am trying to say here is, if you consider this triangle and the parallelogram ABCD, these lie on this base, right. So, this triangle will have area equal to half the area of this parallelogram. Similarly, now if I consider this triangle and parallelogram ABCD, they both of them lie on this base now. So, this is the common base for these two triangles, for these two figures, that is triangle BCQ and parallelogram ABCD. They lie on same base and between same parallel lines, that is this line and this line. Hence, area of this triangle BQC will be equal to half the area of parallelogram ABCD. Now, both these triangles have areas equal to half the area of parallelogram ABCD, hence these are equal areas. Okay. In figure, P is a point in the interior of parallelogram ABCD, right. So, we are talking about parallelogram ABCD, and this is the point P which is in the interior of parallelogram ABCD. Now, what I need to prove here is that area of APB, that is this area, plus area of PCD, that is this area, is equal to half the area of parallelogram ABCD, right. So, for the first part I need to do a little construction. Draw a line passing through P parallel to AB and CD. We know AB and CD are parallel to each other. So, if I draw a line parallel to AB, then it will naturally be parallel to CD. So, I need to draw a line passing through P. And why am I doing that? Because if I draw a line passing through P which is parallel to AB, it will give me a parallelogram here. AMNB is another parallelogram because AB is parallel to MN by construction and AM is parallel to BN because it is given that ABCD is a parallelogram. So, this is another parallelogram. Now, if you notice, ABP is a triangle with same base AB, right, with this parallelogram AB and M, and between the same parallel lines AB and MN. So, this triangle ABP will have area equal to half the area of parallelogram AB and M. That is the purpose of drawing this line. So, what can I say about it? That triangle ABP and parallelogram AB and M are on the same base, that is AB, and between same parallel lines. What are the parallel lines in this case? AB and MN. Hence, area of triangle APB is equal to half the area of parallelogram ABNM, right. And why ABMN is a parallelogram? Although I explained it, let me tell you once again. Because AM is parallel to BN, it is given that ABCD is a parallelogram. So, the segment BN will also be parallel to segment AM. This is a common sense, right. And another line, the pair of opposite sides AB is parallel to MN. This is by construction. This part is by construction. So, a pair of opposite sides are parallel, hence this is a parallelogram. Similarly, I can say about MNCD, it is also a parallelogram. So, area of triangle APB is half the area of ABNM, and area of triangle DPC, is half the area of parallelogram MNCD because of the same reasoning, right. They lie on same base. What is the same base this time? DC. Same base DC. Same parallels. What are the same parallel lines? DC and MN. DC and MN. This is the reason. Now, if I add the left hand sides, what will I get? I will get the left hand side of the desired expression, area of APB plus area of DPC, and what is the right hand side? Half area of ABNM plus half area of MNCD. If I add these two areas, this area and this area, what will be the result? I will get the area of ABCD. So, when I add the right hand sides, it will give me half area of ABNM plus area of MNCD. Now, this sum is nothing but area of ABCD. So, first part is proved like this. Okay. Now, look at this. To prove the second part, what you have to do is you draw a line passing through P which is parallel to AD and BC this time. Okay. Then you will prove that area of APD, triangle APD, is half of, let us say these are MN, AM and D, right. and area of BPC is half of area MBCN, and then their sum is equal to half of area of ABCD. Now, what have you proved here? That area APD plus area PBC is half of area of ABCD. Now, half of area of ABCD gives me another expression, that is sum of areas of APB and DPC, that is sum of these two areas, this area and this area. Sum of these two areas I have already proved is half of ABCD. Now, taking this line parallel to AD and BC, you have proved that these two areas, that is this area and this area, their sum is also half of ABCD. So, these sums are equal to each other, that is this sum is equal to this sum, because both of these are equal to half of area of ABCD. I hope you can do the second part easily. Now, in this figure, PQRS and ABRS are parallelograms, okay, and X is any point on the side BR, right. Now, area of PQRS is equal to area of ABRS, which is obvious because these lie on same base RS and between same parallel lines PB and SR. First part is easy because these lie on same base SR and between same parallel lines SR and PB, right. So, these means I am talking about these two parallelograms, PQRS and ABRS. These lie on same base RS, right, and between same parallel lines PB and SR. Hence, their areas are equal. Hence, their areas are equal. So, area of PQRS is equal to area of ABRS due to this reason that they lie on the same base, which I have mentioned here, and between same parallel lines, which again I have mentioned here. It is important to mention the parallel lines and the same base. Now, you can directly say that these areas are equal, okay. In second part, we have to prove area of AXS, that is this triangle here, AXS is half of area of PQRS. Now, look at this, area of AXS will be half of area of parallelogram ABRS. Why? Area of triangle AXS will be equal to half the area of parallelogram ABRS, because these lie on same base AS and between same parallels AS and BR. Hence, the area of triangle is equal to half the area of parallelogram, right. If a triangle and a parallelogram lie on same base and between same parallel lines, then the area of that triangle is half the area of that parallelogram. So, we have proved that area of AXS, triangle AXS is half the area of ABRS. Now, I know area of ABRS is equal to area of PQRS. So, I can say area of triangle AXS is equal to half the area of PQRS, because area of PQRS is equal to area of ABRS. We have just proved above, right. So, this question can be handled like this. Now, let us look at this one. A farmer was having a field in the form of a parallelogram PQRS. She took any point on RS and joined it to points P and Q. In how many parts the field is divided? Number 1. What are the shapes of these parts? The farmer wants to sow wheat and pulses in equal portions of the field separately. How should she do it? So, let us first of all visualize the problem. There is this parallelogram shaped field. So, let it be the field PQRS. Now, she has taken any point A on RS. So, you can take a point A anywhere on this side RS. I am taking this here. Okay, I am not taking it in the middle. I am taking it anywhere on this side. You can take it in the middle also, right? What are the shapes of these parts? In how many, if I join P, Q and A, in how many parts this field is divided? So, obviously 1, 2, 3. So, we can say the field is divided in 3 parts, right? What are the shapes of these parts? These are triangular regions, or these are triangles in shape. Okay. Third part, the farmer wants to sow wheat and pulses in equal portions of the field separately. So, the farmer intends to sow wheat and pulses in equal areas. Okay. So, how can she achieve that? Look at this triangle APQ and parallelogram PQRS lie on same base, that is PQ, right, and between same parallels PQ and RS. Okay. Hence, I can say area of triangle APQ is equal to half the area of parallelogram PQRS, right. So, area of this sector or this segment of the field or this part of the field, let me denote it by area of this part 2, is equal to half the area of field, right. Now, if I denote this area by A1, this is area A2 and this is the area A3, let us say. What is their sum? It is equal to area of the field. Okay. And A2 is half the area of this field, right. So, what will be A1 plus A3? It will be equal to half the area of the field, right. That means this is a parallelogram shaped field and this area, that is area of this part, is half the area of this parallelogram. So, the remaining area will also be half of this parallelogram. So, what can I say about area A1 plus area A3? That it is equal to area A2. Okay. So, the sum of these two areas is equal to this area. Now, she wants to sow wheat and pulses. So, she has got two options. She can sow wheat in this triangle area 2 and pulses in area 1 and area 3, right. So, wheat here and pulses here, or the other way around, pulses in area 2 and wheat in this area. So, these are the options. Okay. In these ways, she can have equal portions of the field dedicated to wheat and pulses. So, this was about this exercise. I hope you have understood all the questions and the theory part. Thank you.